Now we have another circuit to solve. First we have to transform this circuit into the S domain. So let's do that. In the circuit, this voltage source will be represented the same way in the S domain. We have already learnt about it. However, we have to transform this source waveform VA, and this is an exponential function which will become S plus alpha. So this is our source and R will stay the same. However, for C, we know IC of t is equal to C into dVc over dt. From here, if we want to find out this Vc of t, that will be equal to this one, and using the Laplace transform integration property, that this is equal to this one. So from this one we can replace this time domain capacitor with 1 over Cs plus minus Vc of 0 divided by S. So this one is our S domain replacement for this capacitor. This is Vc of S, and this is I of S. So we have converted everything. So this is our transform circuit or the circuit in the S domain. Now we have to find Vc of t. First let's find the I of S. Applying KVL, we can get minus V of S plus R into I of S plus 1 over Cs into I of S plus Vc of 0 divided by S is equal to 0. 1, 2, 3, 4. 1, 2, 3, 4. And from this one we can find common R plus 1 over Cs into I of S is equal to Vs minus Vc of 0 divided by S. So we don't need this expression anymore. So I of S is equal to 1 over R plus 1 over Cs into Vs, and for this Vs we can now replace Va divided by S plus alpha minus Vc of 0 can be replaced with the initial condition value, which is V naught over S. So I of S is equal to Va divided by S plus alpha into RCS plus 1. So this Cs will go up since we have taken the LCM. RCS plus 1 over Cs. So Cs is gone to the top of this 1, and further minus this will go the same way with this one. So 1 over RCS plus 1, and Cs has gone to the top side, and V naught divided by S. Further, this S is cancelled out with this one. So what we have now here is VA into C into S divided by S plus alpha. For simplicity, we always keep S separate. So from this one, we can take RC as common. So RC is taken as common. What is left is S plus 1 over RC minus, similarly we will take RC common here, S plus 1 over RC into V naught. Further we can simplify it. I of S is equal to VA divided by R is like a coefficient into S divided by S plus alpha into S plus 1 over RC minus V naught divided by R and whole divided by 1 over RC. Okay, so we have obtained the expression for the I of S, and we can also take it into the time domain as well by taking the inverse Laplace transformation. However, we have not been asked to find out I of t. We have been asked to find Vc of t, and according to the, by watching the circuit, according to the KVL, by KVL we can see Vc of S is equal to 1 over Cs into the current, which is I of S, since this is already in the phasor form, plus the Vc of 0 divided by S. And here clearly we can see that we have to substitute this value over here for I of S. So what we are going to get is Vc of S is equal to 1 over Cs into Va divided by R divided by S plus alpha into S plus 1 over RC, and then further minus 1 over Cs into V naught over R divided by S plus 1 over RC, and plus this Vc of 0 divided by S. So actually we have substituted the value of I of S here. Now we can simplify it, and let's solve it on this side. What we have obtained is Vc of S is equal to V naught Va over RC. I have taken this C with R divided by S plus alpha into S plus 1 over RC. Further minus, I can also take this C with this R, V naught divided by RC, V naught divided by RC, and divided by S into S plus 1 over RC plus Vc naught of over S. Vc naught, the initial condition is already, we know that value is given as V naught, so we can replace that as well. V naught divided by S. So we have obtained this expression for Vc of S. We have to take the inverse Laplace transformation, but we cannot take the inverse Laplace transformation in this formation because we see this is the proper fraction. However, we have to do the partial fraction here. So first we can solve this one, which is, let's say, Va over RC divided by S plus alpha into S plus 1 over RC is equal to A over S plus alpha plus B over S plus 1 over RC. Simplifying this, multiplying both sides with the denominator factors, we will get A into S plus 1 over R C plus B into S plus alpha. For value of S is equal to minus 1 over RC, what we are going to get is VA over RC is equal to minus 1 over RC plus 1. This will become 0, and we will have S is equal to minus 1 over RC plus alpha. So we have the V value is equal to, taking this to the other side, we have VA over RC into, actually it will be going in the denominator since this factor is being multiplied with B, so this will be alpha minus 1 over RC. So this is the value for B. For S is equal to minus alpha, this will help us to get the value for A. VA divided by RC is equal to A into S is replaced with minus alpha plus 1 over RC, and minus alpha plus alpha is 0, so we are going to get value of the A, which will be VA divided by RC, and this will go to the denominator on the other side. However, we have to write it minus alpha plus 1 over RC. Rather than writing this, we can also take the minus common, so this will become alpha minus 1 over RC. Why did I do it? Just to make it look like similar to what we have in the B, in the value of B. So we have got these factors, these values for A and B in this one, and similarly we have to do the partial fraction for the next one, and we can do that. Let's do that. We can actually remove this one. So doing the partial fraction for the RC divided by S into S plus 1 over RC, A over S plus B over S plus 1 over RC, and multiplying both sides with these two factors, we are going to get V naught over RC is equal to A into S plus 1 over RC plus B into S. Now for S is equal to 0, this will become 0, this is 0, so the value for A will be V naught over RC, and 1 over RC will go to the other side and will become RC. So we have got value of A is, let's write it here, A is equal to V naught. We can also remove this one since we don't need. For S is equal to minus 1 over RC, S is equal to minus 1 over RC, this will become 0, so V naught over RC is equal to, this is going to become zeros, and B into S is minus 1 over RC, so this RC is cancelled out, so we got B is equal to minus V naught. So we have all the values, and that is already the sole factor. So let's write the complete equation. VC of S is equal to, first we will write this one, A, and the value of A is given there, minus VA divided by RC into alpha minus 1 over RC divided by S plus alpha. Next is B. The value of BV is actually similar, except the change in the sign, S plus 1 over RC, and the next is minus. For this one, for this we did the partial fraction here, and for this we have done the partial fraction here, this one. So minus, we are going to replace it with this one. So A is V naught divided by S, and further that will also be minus, and minus V naught divided by S plus 1 over RC, and the last term is V naught over S. So we have got this one, and we can write the final solution here on this side. Now taking the inverse Laplace transform of this one, taking inverse Laplace transformation, we are going to get the answer on this side. VC of t is equal to minus VA over RC into alpha minus 1 over RC, and this one according to the inverse Laplace transform table will become minus alpha t, plus VA divided by RC into alpha plus 1 over RC e to the raised power minus 1 over RC into t for this one. And then the next is minus, actually we can clearly notice here this plus V naught over S and minus V naught over S is actually cancelled out, so we don't need to write them. However, minus minus plus, so this will become V naught into e to the raised power minus 1 over RC into t. So we will actually multiply it with u of t, the unit function, and this is our required VC of t is our the answer. So this is the solution.